Hello viewers, welcome to Elimu TV. I'm your tutor Alex Musa and I'll be taking you through Chemistry Form 2, Lesson 26. Our topic is Structure and Bonding and our subtopic is Ionic Bonds. What are the objectives of this lesson? Number 1, to state the significance of valence electrons in bonding. Number 2, to explain qualitatively the formation of ionic bonds. When atoms of the same or different elements combine during a chemical reaction, a force of attraction develops between them. The force of attraction holds the particles together and it's called a chemical bond. Chemical bonds hold the particles of a substance together and they form a certain kind of pattern called a structure. What is an ionic bond? An ionic bond, it is also called electrovalent bonding. It involves complete transfer of valence electrons from one atom to another. This results in the formation of ions with opposite charges which attract each other mutually. Let's say for example you have sodium and chlorine. Sodium atom reacts by losing its single valence electron to the chlorine atom. The resulting sodium particle has 10 electrons and 11 protons. This results in the formation of a sodium ion. As you can see, when sodium loses an electron, it gives chlorine 1 electron, and this results in the formation of sodium ion and an ion of chlorine, which is chloride ion. The sodium ion with a net positive charge and the chloride ion with a net negative charge attract each other. The electrostatic forces of attraction develop between the ions. It is called an ionic bond. So, an ionic bond is formed when there is complete transfer of valence electrons from one atom to another, resulting in two ions with opposite charge. Sodium has a positive charge and chlorine has a chloride ion has a negative charge. What are some of the examples of ionic bonds? Sodium and chlorine is one of them, we have seen. Aluminium and bromine is another example of ionic bonds. Potassium and oxygen also form an ionic bond. Magnesium and nitrogen also form ionic bonds. Potassium and phosphorus also form ionic bonds. The next is giant ionic structures. Giant ionic structures. Consider sodium chloride. Sodium chloride consists of many sodium ions and chloride ions that are arranged and packed in a regular pattern. As you can see, each sodium ion is surrounded by 6 chloride ions that are equidistant from each other. This pattern repeats itself many times, and this leads to the formation of a giant ionic structure. Most ionic substances are crystalline in nature. Examples of substances with giant ionic structure are potassium nitrate, sodium iodide, potassium bromide, and calcium nitrate. The ions in a giant ionic structure are arranged in a regular lattice. That means a repeating pattern of elements. What are the physical properties of ionic compounds? Ionic compounds, they are soluble in water. Most ionic compounds are soluble in water. They have a high melting and boiling point. This is because ionic bonds are strong. Melting and boiling involves breaking these ionic bonds. A lot of heat energy is required to break their bonds. Ionic compounds do not conduct electricity in solid state. As you can see, they cannot conduct electricity in solid state. This is because the ions forming the structures are not mobile but occupy fixed position in the structure. However, in molten or aqueous solutions, the ions can conduct electricity. The ions, because they are mobile in molten or in solution form, and therefore they can conduct electricity. And those are some of the physical properties of ionic compounds. And that is the end of our lesson. Question. Explain why the melting point of ionic compounds is high. Number 2. Explain why ionic compounds conduct electricity in molten states and in aqueous solution but not in solid state. Our reference is KLB Book 2, 5th edition, 2019. For more information, contact us on our number: YouTube Elimu TV, Facebook Elimu TV, and on Twitter at Elimu TV _KE. Thank you for watching Elimu TV. Stay tuned.